Hi, my name is Ben. I'm a software engineer and a student at UCF getting my graduate degree, more specifically my master's in computer engineering. And this video today is about my semester project for my graduate level computer operating systems class. And more specifically, the class itself is this one. Operating System Design Principles, COP 5611. And what I will be demonstrating is my semester project, which is a manufacturing test software suite, which includes the test station software, the unit under test software, and the basic architecture as you see right here, test station, unit under test, and then you got your devices like digital multimeters, oscilloscopes, and things like that. What we'll be concentrating on is the embedded test software architecture, which includes the embedded web server, completely developed from the ground up using socket programming, ATP tests, which are run directly from the test station one at a time, and then you got your ESS environmental stress screening tests running under the ESS OS infrastructure of the ETS. Basic class diagram of the ETSS. This is how your all tests will be created the exact same way. They will be launched exactly from the same spot, just like this. And this is the class diagram that's going to be used, and each test will be just another function pointer here for the test name. So basic class diagram for each test, and each test will be created exactly the same way in this application framework that will be explained later. So, well then, let's get on with the demonstration. So what we have here is we're going to use the Windows computer as the test station software, the front end, and that's a Whiskey server, and we're just going to launch it via Flask. We don't need to launch it through a production deployment server such as Waitress or Gunicorp, I think it's called, the other one. It's fine. So we're gonna launch it like this for today, and we'll SSH into my Linux machine. Okay, we'll move this one out of the way. We'll launch a console terminal. We'll navigate to the development folder, my semester project, and we'll just do a make clean, and we'll do a make to make sure that everything is fresh and running at its optimal state. Okay, so let's run it. And we'll navigate to the ETSS software folder, and we'll run the software. Okay, first thing that you see is the ETS shell. Right now there's only 3 commands. We will start the server so we can have communication between test station and unit under test. Server is running, and now we can actually go, and we have our test station server running as well. And now we can navigate to localhost, port number 8484. We'll start with the ESS tests first. Okay, here we enter the mask. There's 3 tests total here that's been implemented, and the IP address 192.168.1.105:8080, and the mask is binary mask, and the way that works is I'll illustrate here with a Windows calculator. Basically in binary, if we want to run all 3 tests, we have 3 ones, which is equal to 7. If we want to run just the first test, it's just 1. Let's say we want to run the first and third test, then it would be 1, 0, 1, which would be 5. But we're going to do all 3 tests. So the mask will be 7. Okay, let's launch it. And there we go. There's test ID 2, test ID 1, test ID 3. All 3 tests are up and running, and they're all running without any faults. Everything is passing. So what are we running here? Well, let's look at the output of the unit under test. What we are doing is we're doing memory testing via shared memory. We're doing CAN bus testing, and I have a simple CAN bus simulator in my utilities library. And we're doing Ethernet testing via ping. So test 1 is Ethernet testing via ping. I just use the ping utility that comes in Windows, and I just do a fork exec, and in that case I wait for the process, and once it's finished and gives me the results, then I return the results to the test. In the CAN bus test, we just send data across to the simulator, and it loops right back to me. And for the shared memory test, I'm sending 1 byte at a time, and you'll actually be able to see that here when I stop it. But if you look very closely, I can actually see the shared memory data going across. And the way I check that to make sure that it's all correct is I use a IPC queue, and in my utilities library I have an IPC queue function that does all the system calls. I encapsulate them into a function, and then all I do for my test is just call that to the library that's part of this project in my utilities dynamically linked library. And that's how I decide whether the data actually made it across or not. So, which means we can actually inject a fault. So let's inject a fault by simply, let's just launch a new terminal. I think that will be cleaner. And we go to the client, and here we can launch the client manually. And here, if we send in a queue, this will kill the shared memory server, which should produce a failure. Now the tests are still running. That did not produce a failure. There we go. It didn't take because the software sent in the data first, and it was reading the data that was being overwritten, and it wasn't very clean, and I was the test was overwriting my me trying to sabotage the server, but I managed to do it, as you can see. And there we go. Now we have failures, and we've got error codes for test 3, as shown here. And it's error code 13 because it's got multiple errors, and those errors we bitwise OR. Okay. So to conclude the demonstration, I'm going to stop all the tests and restart them again. And if you notice, the tests now are passing, but it's still red. Well, it remains red because industry standards dictate that once a test fails, it's going to remain failed unless it's deliberately cleared by the test technician. So we'll stop the test again. We can watch them stop. And we'll clear, and we'll restart them again. And there we go. Now it's back to green. So we'll go ahead and stop. And you can tell here. Here's where I was checking the results of what I sent, and if you scroll up here, this is what I was actually sending. As you can see, the server, shared memory server, actually received A, and I got A back on the IPC queue. So I'm also reading a queue because the server is populating a queue, and I read that back. And it is a thread safe queue. That's part of the operating system calls. For inter-process communication, and then when I sent in a stop, the server got a queue to quit, and it did quit, and then the task itself terminated. The ATP shared memory test terminated correctly, including all the other tests. Okay, well this concludes this demonstration. Oh yeah, one more thing before we go, really quickly, just to show for completeness sake, there is the ATP software as well, but this will go very quickly because there's only 3 tests. And there we go, there's only 3 tests. And these are all just testing the utilities library, my dynamically linked library that I have all my simulators and other things in there. And to exit everything, just simply close it. Control C from the test station software. Over here, we can either do exit or stop server first. Either way will work. I'll go ahead and just do exit, and as you can see, it worked. And that concludes our demonstration. Thank you for listening, and if you like boring content like this, please do like the video. If you don't like boring content, then go to Enigma Climbing.